Sorry.
Look at the camera.
Position.
Look at the camera. Don't look at my position.
No, we're looking at the camera. Is
Okay.
this how you got this job, sir?
Hello, welcome to Mr Yazdan's channel. We have a new video for you with my year 11 students. They're going to take you through the magnetic levitation. Let's see what they have made for us.
3, 2, 1.
Action.
So this is the levitation project by Michael, Gio, and Jordy. We decided to do this project because we thought it'd be a fun and easy way to show off physics with something as simple that everybody can do at all ages. So we decided to do levitation using magnets.
Keep going.
Jordy, it's your turn. You know that, right? It's your turn, you know that.
Will we
Right?
make an object? It's a pencil this time.
Wait, I'm
Float.
covering it.
We'll be using
Nice top.
north and south poles of a
I just got
magnet
it,
to create a
actually.
magnetic field, which creates like a repel and attraction force. And because we're using south on south,
Should we
north on
start because of
north,
the time?
it creates.
Okay.
I think we should just.
Why you gotta interrupt me, man?
So what are the use of the levitation? You guys tell us.
The main thing we really liked about levitation was how it's gonna be used in the future for transportation. We thought how efficient levitation and the use of magnets and electromagnets in transportation, especially with the example here of the trains, really to advance the future of transportation.
And it would allow us to go faster because
Yeah,
we don't
much
have contact
faster.
to the ground, so there's no.
And there's more secure
What will go
travels as well.
faster?
Because there's no friction because we have no contact to the ground.
So less drag force.
The only thing stopping you would be the air resistance.
There was this thing.
And you can see from the shape of the trains, the way they're using it, they've actually made it more pointed to cut down the amounts of air resistance on the object.
Brilliant. So like you can see here, that's the simplest form of levitation.
Yeah.
They've done. So I can see 2 bar magnet here.
Yeah.
Both are pointed up the same pole, and you have the round magnet, circular one. Yes.
Yes.
And
Yeah,
so a pencil gone through it.
And the cardboard.
Cardboard as a base, and you have these plastics around it. What is that reason for it?
So one of the issues with the project, with the levitation project we built, is the bar magnets were pushing up, and the round magnets, the ring magnets, were levitating, but then slowly falling to the side because of the way the magnetic force was working. So in order to stop that, we put a base around it to hold these firmly in place.
So between this green one and the red part here, I can see here it's lifted up, so it's on the air. So it's being pushed up by the magnet.
Yeah.
So I'm just gonna get closer, see if I can get it in camera. Let me just.
Is it levitating or has it?
Yes, the green one. I'm just trying to get it.
Place them like.
Here we have another model, 4 round magnets, 2 neodymium magnets, very strong, one here, one the other side. I have used a plastic sheet, so roll it, made a tube, and stick the magnets in both sides. When you're putting these 2 magnets next to each other, you have to make sure they're repelling each other. Same for the other side. And also, when you are placing the neodymium magnet in the top, these should repel those as well. So it's all about repulsion. That's why it would float in the air. At the end, I have added a pin. So that pin is to stop the magnets to be pushed forwards. So it goes out into the wall, for example. Other than that, it's not holding the bar at all. So that's the pin stuck to the magnet. Empty tube of plastic, you can use anything, even cardboard, and that's the levitation. You can even turn this, I guess you can, let's see, spin that, it will turn. So magnetic levitation. If you find this floating cylinder boring, like me, take the magnets out, stick them in the both sides of the battery. Make sure the both are facing out are the same pole, for example north and north. So aluminum foil, and you will see it works like a motor, the simplest motor you can make.
Thank you so
But
much, sir.
Thank
for
you
being
very much.
amazing.
You're welcome. Thank
Thanks,
you.
sir.
T-shirt.
You're welcome. We have a pleasure of shaking Mr. Yazdan's hand.
Yeah, met a celebrity today.
Yes, like-
Yeah.
Yeah.
Well, thank you very much for watching our video. And thank you again. Please don't forget to share, subscribe.
Buy the merch.
Buy the merch.
Incoming,
It's
soon
not
to
out
be dropped.
Yeah, it's not out
Yeah.
for sale.